Hello and welcome to Maskit Laboratory. Today we are going to take a look at chemistry as a science subject. And in chemistry, we are going to take a look at a topic that is acids, bases, and indicators. And then we also take a look at the properties, that is the chemical and physical properties of acids, bases, and indicators. So with me, I have a range of acids and bases. I also have some of the types of the indicators, that is, which is normally used to test for the acidity and basicity of some of the substances. So we normally use it to test for the pH, which we'll also take a look at. We have another type of indicator, which is the methyl orange indicator. The function of the methyl orange indicator is to tell if a substance is a base, a neutral, or an acid by changing its color. We have another type of indicator, which is the phenolphthalein indicator, which is also used to tell if a substance is a base, an acid, or a neutral substance. Apart from the indicators, I also have a wide range of bases. I have strong bases as well as weak bases. I have strong acids like the nitric acid, and I also have weak acids, the likes of acetic acid and oxalic acid. So we'll take a look at most of the properties of bases and acids, and then apart from the properties, we take a look at the application of such properties. So without taking much time, I would like to take a look at the definition of acid. So an acid basically is a substance that when you dissolve in water will dissociate from hydrogen ions as the only positively charged ions. And we have examples of acids. One of the common examples of an acid is hydrochloric acid. We have another type of an acid, which is a sulfuric acid. Another type of an acid is nitric acid. We have another type, which is the carbonic acid. Of an acid, which is this is ethanoic acid. It is an organic acid. So ethanoic acid is a organic acid that is a carboxylic acid, and it has a formula C. This is CH3COOH. For those who've done organic chemistry, that is a carboxylic acid. I think this is not new to you. And carboxylic acid is normally a weak acid, and we'll take a look at the reason why it's a weak acid. So these examples represents the acidic substances, and all of them have acidic properties. And the reason why they have acidic properties is because when you dissolve them in water, they dissociate to keep hydrogen ions as the only positively charged ions. We'll take an example of HCl. HCl is normally in concentrated state before you dissolve it in water. So it is normally in liquid state. And in liquid state, HCl has hydrochloric, that is HCl molecules. And the moment you dissolve this in water, the HCl, that is hydrogen, and the chloride ions dissociates, giving hydrogen ions as the only positively charged ions, and the chloride ions as the only negatively charged ions. And because of that, then we have chloride ions and hydrogen ions. Therefore, presence of the hydrogen ions makes hydrochloric acid acidic. So the acidic property of acidic substance is due to presence of hydrogen ions when dissolved in water. If you take a look at the dissociation of sulfuric acid, which is H2SO4, concentrated form, that is a liquid form, will dissociate in water to give hydrogen ions as the only positively charged ions, and the sulfate ions. So the hydrogen ions are the ones which are responsible for the acidic property of sulfuric acid. And this will be in solution form, so it becomes aqueous. This is 2. Since the number of hydrogen on the reactant side, that is before you dissolve it in water, is also 2. Sulfuric acid in liquid form doesn't possess the acidic properties. But the moment you dissolve it in water, it dissociates to give us hydrogen ions, which are responsible for the acidic property of sulfuric acid. So hydrogen ions are the ones which are responsible for the acidic property of any substance when dissolved in water. In liquid form, we only have acid, that is the acid molecules, which have no property, that is, they have no acidic property. And that is why in liquid form, most of the acids doesn't react as a typical acid, because there is no hydrogen ions which are responsible for the reactions, that is the typical reactions of the acids. So that is example of dissociation of acid in water. And I would like to maybe take a look at the difference between strong acids and weak acids. In lower secondary, we normally take a look at strong acids as those acids which have a lower pH, that is a pH of between 1 and 3. And we also take a look at weak acids as those which have a higher pH, that is a pH between maybe 4 and 7, that is between 4 and 7. We know those which have a pH of 7 are normally neutral. So I would like maybe to take you through the pH scale and show you the difference between strong acids and weak acids. So we know the pH scale is a range of numbers from 0 to 7, 0 to 7, and then from 7 to 14. So this is 7, 0. We know those substances which have a pH of 7 are neutral. So any substance that has a pH of 7 is neutral. Any substance that has a pH of more than 7 is a base. So between 7 and 14 we have bases. Between 0 and 7 we have acids. So strong acids normally have a pH of less than 3, and weak acids normally have a pH more than 3. Strong bases normally have a pH of more than 11, while weak bases normally have a pH of less than 11. And we have the likes of ammonia. So ammonia is an example of a weak base. For strong acids, we have examples of potassium hydroxide, that is KOH. We have examples of sodium hydroxide, that is NaOH, and similarly calcium hydroxide, which is partially soluble in water. So these are strong bases, these are weak bases. So we have ammonia, we have ash, we have ash, which is also another example of a weak base. On the side of acids, we have strong acids, and strong acids are the likes of nitric acid, which is HNO3. We also have sulfuric acid, which is H2SO4. We also have hydrochloric acid, which is HCl. On the side of weak acids, we have the examples of that is carbonic acid, that is H2CO3. This is carbonic acid. We have ethanoic acid, which is CH3 COOH. These are just a few examples of weak acids and strong acids. Now, strong acids normally have a pH of less than that is 3, while weak acids have a pH of more than 3. And the reason why we have these substances being weak acids is because they don't dissociate completely in water to give us hydrogen ions as the only positively charged ions. If you take a look at carbonic acid H2CO3 dissociates partially in water to give us hydrogen ions, which is H positive, and HCO3, which is the hydrogen carbonate ion or radical, with that is HCO3 radical. So this one, in this radical here, we still have some hydrogen ions or some hydrogen atoms, which shows that there is no total dissociation, and because of that, then it becomes a weak acid. The same happens to ethanoic acid. Ethanoic acid does not dissociate completely in water. So if you dissolve ethanoic acid in water, it undergoes partial dissociation to give us hydrogen ions, and the ethanoid ion, which is the COOH ion. And because of that, then there is incomplete dissociation. So due to this property, then we say this is a weak acid. This is a weak acid. But for the cases of nitric acid, sulfuric acid, and HCl, they all undergo complete dissociation to give us hydrogen ions. So the number of hydrogen ions in a strong acid are normally more than the number of hydrogen ions in a weak acid. And because of that, then we have weak acids and strong acids. So that is the difference between strong acids and weak acids. So from what we've seen, we can give the definition of a strong acid and a weak acid. Ions, and we have examples of strong acids. One of the examples is HCl. So one example is hydrochloric acid. We have sulfuric acid and nitric acid. So those are the examples of strong acids. On the other side, acids. ions, but the dissociation is partially, not totally, like in strong acids. So that is the difference between a strong acid and a weak acid. And the examples of strong acids are these ones: HCl, sulfuric acid, and nitric acid. Examples of weak acids are carbonic acid, ethanoic acid. We have tartaric acid, among many others. So that is the difference between a strong acid and a weak acid.